Hello viewers, welcome back to class. I'm super excited to welcome you back again to Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos. And don't forget our policy, do not skip any part of this video. This is for your own advantage. And ensure that anytime you are set to learn new concepts from this platform, avoid every unnecessary distraction. Pay close attention and ensure that you give maximum focus to what we teach. And finally, if there be any part in this video that you do not understand, when you watch it for the very first time, guys, you have the singular opportunity to replay the video over and over and over again until it sinks into your mental capacity. Very important. Believe that you can understand this and you will certainly understand it in a grand style. Now listen carefully, guys. We have been examining the concept of differentiation of functions in calculus. We have looked at different differentiation of functions, and now we are looking at logarithmic functions. On the board, we have logarithmic functions. Now, in logarithmic function, there is something I just want you to understand. Logarithmic function is a combination of two product functions or a product and a quotient function. What do I mean? A logarithmic function comes in such a way that you have more than two functions at a time. Unlike product rule, we have two functions that multiplies each other. For quotient rule, we have two functions that divides each other. While we have one of the functions at the numerator, we have the other at the denominator. But in the case of logarithmic, how do I identify logarithmic function? This is when I have more than two functions. Either the product of more than two functions or quotient of more than two functions. So when we look at the board, we discover that these functions are given in this form. It's either y is equal to u multiplied by v multiplied by w. You see now we now have w third function. So this is a part of it that has three functions. You can have four functions, five functions as the case may be, but understand that logarithmic function comes in when you have more than two functions in a given function. And understand that all of these functions that we have here, they must be in respect to what x. So it can come in this way, or you have u and v at the numerator while w comes to the denominator, or you have only u at the numerator while v and w are at the denominator. For three functions, these are the basic three ways the questions can come. And very quickly, we are going to be solving one question each using this formula. Now, from this case, we have that if we just said that where u, v, and w are all functions of x. So if I am to differentiate if y is equal to this, which is the product of three functions, not two functions now, product of three functions. All I need to do is to have dy over dx is equal to y, which is the given function, multiplied by 1 over u, multiplied by dy over dx, plus 1 over v, multiplied by dv over dx, plus 1 over w, multiplied by w dw over dx. For this first case, everything is positive. So understand that product, when you have the product of two or more functions, you add up their derivatives. But when you have division, you subtract. So for this other case 2, if y is equal to uv over w, then dy over dx is equal to y, which is this given function, open bracket, 1 over u du over dx at the numerator. So all numerators are positive and all the denominators are negative. So u and v are at the numerator, and so you see that they are positive. But w, which happens to be at the denominator, is negative. Now for case 3, we find out that only u is at the numerator and only the numerator is positive. all the functions at the denominator, their derivatives will be negative. Therefore, you find out that 1 over b is negative and w is negative. So all I want you to understand from here is that for you to be able to solve logarithmic function very well, you must understand the relationship between the functions. When the relationship between all the three functions are multiplication, then you will add up their derivatives. And also, when you have functions at the numerator and you have some at the denominator, numerators are positive, denominators are negative. If this is understood, then what is the next option? The next option is that for me to always get the derivative or the general solution, the y over the s, I always understand that it will always be u 1 over the function, multiply the derivative of that same function, then 1 over the function multiplied by the derivative of that same function. Now on the board, we are going to be using shortcut. We may not use these formulas, but you need these formulas to be in your mental capacity to have this done. But the simplest formula that I need you to know, since we are dealing with objective or we are tending to objective students, is that you should know that any function that you have at the numerator, they are positive, and those at the denominator are negative. If this is understood, let's quickly look at the very problem that we have before us. Now we are asked to find the y over the x, we are asked to find y prime, we are asked to find f of s prime, or we are asked to find the first derivative of this function. So to find the first derivative of this function, all that we just need to do, guys, is to look at the relationship between the functions and equally identify the functions. Now, let's look at it. This is A. We have y is equal to x. We already put down our solution for exponent 3x tan x. This is equivalent to u v w. Are you here? This is equivalent to u v w. I'm going to be using shortcuts. Alright, so I will not be using the formula. How do I use shortcut to solve this problem? Understand first the functions that you have, or identify first the functions that you have. Here we have polynomial, here we have exponential function, and here we have a trig function. Is that it? Trig function. What I need to do is to have dy over dx is equal to, just follow me, we are using shortcut. Put down everything about y. Everything about y is x raised to power 4 exponent 3x tan x. See guys, we are still making use of this formula. This is the y. You see that for every of the functions you have here, you always have y before the opening bracket. Then this is the first term. Are we there? So all you need to do now, see, listen, we are using shortcut. This is the first term, which is x raised to power 4. When you differentiate this, we have 4x raised to power 3. So put it down, 4x raised to power 3 as the numerator, then the denominator becomes the function itself. And the function is s raised to power 4. This is how this is done. First, differentiate the function, put it down as your numerator, then put down the function itself as the denominator. No, you may not get it yet. Now let's look at number 2. Number 2, identify the next function, which is exponential function 3x. Now, if I differentiate this, just differentiate the exponential function 3x, and you're going to have 3 exponent 3x. So put down this, which is 3 exponent 3x, all over the whole function, the given function. It's as simple as this. Then plus, the next is what? We have tan, that's the last function. When we differentiate tan x, we will have sec square x. So put down the derivative, sec square x all over. Now, the denominator will always be the function itself, tan x. Now, guys, with this method, in 2 steps, you will get your answer. This is for objective students. Alright? Now, therefore, finally, we have our answer as x raised to power 4 exponent 3x tan x, open bracket. Now, s cubed will cancel s squared, s raised to power 4. Now, if I have x raised to power 3 over s raised to power 4, this is the same thing as what? 1 over x. Is that correct? 3 will take care of what? 3 here. Otherwise, you can have this x multiplied by x all over x multiplied by x multiplied by x multiplied by x. If this case is how you understand it better, this takes care of this takes care of this takes care of this. So at the numerator now we have 1, and at the denominator we have x. So when we multiply 1 over this by what we have before, that means this will be what 4 over x plus exponential 3x cancel exponential 3x. We are left with what? Just 3. Then plus there is no trig relationship between these. Then this becomes sec square x all over tan x. This is the answer to this very question. Question number 2. B. Y is given as s squared sine x over cos 2x. So I have that the y over the x. For shortcut, all you need to do, repeat the given question first. And that is x squared sine x all over cos 2x. Now open bracket. Now at the numerator, I have two functions, which is polynomial and trig. So the polynomial is u. Understand that this is equivalent to uv over w. Is that correct? U is this guy, v is this guy, and w is this guy, which agrees to case 2. You can adopt this formula. Are you there? It agrees to case 2, so you can adopt this formula. But here, we are not using formula. We are solving direct because this is for objective students. Now, all I need to do is to identify the first function, which is s squared. When I differentiate s squared, I will have 2x. So put down 2s as your numerator. Now put s squared as your denominator. Now, the relationship between u and v are all at the numerator. I will say all functions at the numerator must be positive. So this is positive. This will also be positive. Now, all I need to do is I identify the second function. The second function is sine x. Now, guys, if I differentiate sine x, I will have cos x. So what do I do? I'll first of all put down cos x, which is the derivative, all over the function itself. Then minus. Why are we using minus? We said that any function at the denominator is always negative result. So we put down minus. Then we identify the function at the denominator, and that function is cos 2x. Are you here? Now, if this is cos 2x, when you differentiate cos 2x, what do I say you do? First, you can use simply a function of a function here. Differentiate 2x. You will have to put down 2. When you differentiate cos, you have negative sign. Then pull down the 2x. This is what you have. So you will pull down this now all over the given function. The derivative over the given function. So the derivative here is negative 2 sine 2x all over cos 2x. So as simple as this. So the next thing we quickly do is to cancel out in one step, and we are done. Now all we do here is to have this s squared sine x over cos 2x, then open bracket. Now for these guys, we have that s will take care of 1x, then this will be 2 over x. Then plus. Now understand that cos over sine under trig identity is cot. So I can replace cos s over this as cot x. This is simple form. While sine over cos, now understand that minus multiplied by negative 2 would have given us plus 2. Now, sine x over cos x is tan x. That is to say, sine 2s over cos 2s will give us tan 2x. Then this will have given us tan 2x. This is the answer to this very question. You see that it's very, very simple, but you need to understand the principles. Shortcut only. Forget, nothing is difficult. All you just need to do is to give your time and the willingness to get to know true facts is what makes you outstanding. When you know principles, you become a principal. When you understand boundary conditions, you will never overstep your boundaries. So at this point, if you have not subscribed to this YouTube channel, please subscribe to this YouTube channel and ensure that you turn on the post notification bell so that when next we upload video, guys, you will be notified. This is the reason why you should turn on the post notification bell and understand that you cannot turn on the post notification bell if you have not subscribed to this YouTube channel. You enjoy all our free classes. Now, question number C. We are given that y is equal to, alright? We are given that y is equal to exponent 4x all over x cubed all over x cubed, then cos 2x. Now, in this case, we understand that this is equivalent to u over vw, because we have only one function at the numerator and two functions at the denominator. This is the first thing you will always do to identify the functions and their positions. So now I have three major functions again: exponential, polynomial, and hyperbolic function. This is not cos, this is cos 2x. So what do? We understand that the y over the x is equal to, pull down the whole question you will do, exponent 4x over x cubed cos 2x. Now open bracket. The first thing you do is to pick the u, which is the first function, exponent 4x. When you differentiate exponent 4x, you have 4 exponent 4x. So pull down this over the given function to 4 exponent 4x over exponent 4x. Now, the next function is v, and this is at the denominator, and we said all functions at the denominator have negative results. Now, I have that as x cubed. When I differentiate x cubed, I'm going to have 3x raised to power 2. Then I will put down the derivative first, which is 3x raised to the power of 2 all over the given function, which is x cubed. Then finally, the w, which is the third function, is equally at the denominator. Then we have negative sign. Now, when we differentiate down, the function there is cos 2x. When you differentiate cos 2x, you have 2 sine 2x. All that just happened here is to bring out the coefficient of x. Then, when you differentiate cos x, you have sine x. So this is the result for this. So we are going to put down this first, followed by this. Then we have 2 sine 2x over cos 2x. So finally, dy over dx is equal to the y function that you are given, 4x over x cubed cos 2x. Open the bracket now. Exponential 4x, we cancel exponential 4x, we will be left with 4 minus x squared divided by x cubed would have had 3 over x. I told you anytime you differentiate polynomial function, you will always have a constant over x. That's exactly what we equally have here. Then minus, understand that this is minus 2. Sine 2x over cos 2x would have given us tan 2x. Just the same way we have sine x over cos x is equal to tan x. Then if I have h here, I have h here, it's the same, which is tan. So this would have given us tan 2x. This is the answer to question number 3. So guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos when being uploaded. What do you need to know here? Understand that for a logarithmic function, you have more than 2 functions, and you need to always identify the 3 or more functions that you are given by the category of functions they belong to, and also identify the position, whether they are at the numerator or at the denominator. These are the basic things that you should know about this. So if you do not understand what we have done so far, guys, you have this singular opportunity to replay the video over and over again until you understand it. But if at the end of watching it over and over and over and over and over again, you still have questions to ask, guys, don't hesitate. Just go down to the comment section and make your necessary comment, whether as question, as an appreciation, or as a suggestion or observation. So guys, don't forget, as usual, the link to the next lesson is located at the description below. Don't forget, share this video, like this video, and ensure that you don't miss our next lesson. See you guys in the next class. Thank you for watching.